Okay, so this is the last puzzle for this unit 9 and 10 that are combined together. And what we're going to do is we're going to look at the integrals of e to the x's or e to the u's. Okay, so just like we know the derivative of e to the u is, because of the fact that sometimes it's not just x, or just one letter, it could be e to the 2x squared. The derivative is equal to the carbon copy times the natural log of the base, which we know that it's just going to cancel to 1. And then it'll be times the derivative of the power, which would be 4x. So the answer to this one would be 4x times e to the 2x squared. Okay, that is the derivative as far as exponential functions go, especially when their composite functions are in the power and not just straight up just letters. Now, so what we're going to do is we're going to do the integral now. So the integral, just like the derivative of e to the x or e to the u is e to the u, we can say the derivative of e to the x is e to the x. Okay? Most likely we're always differentiating in respect to x. So because of that, this right here goes the carbon copy times the natural log of the base times the derivative of the power. So it's just an understood e to the x goes to e to the x. Okay? Just reminding you that e to the u is most likely going to be a composite like we're talking about here. That's why we choose to do this du dx piece, because we're always making sure that we're deriving. So the integral going backwards of e to the x is also going to be, when it's in respect to x, it's going to be e to the x. So just like it's the same thing going forward, if and only if that variable is x and only x, it's going to be the same thing going backward. Okay? So looking at it like this, it will be e to the u, whenever it's in respect to u, will also be e to the u plus c. If it was the integral over here, the way we were showing in respect to x, it would also be e to the x plus c. Okay? So now let's look at this. The reason why I can't just say this is going to be e to the stuff plus c is the fact that this is not just one letter. It's not just the letter that is written there that's in respect to. So if it was e to the x, yeah, it'd just be e to the x. If it was e to the u, which it is, we're going to have to do a little bit more. We're going to do u substitution. So u is equal to 3x plus, whoops, let me write that a little bit better, 3x plus 1. Du, the differential, is equal to 3 dx. And just like we've been doing with prior stuff, we're going to do this as a rewrite of 1/3 e to the u. Again, I'm saying e to the u because of the fact that I have replaced it with this. It is now in terms, or sorry, in respect to du, so I'll write that there. And we know that this is going to equal e to the u plus c, but it's going to be multiplied with 1/3. So e to the u plus c. Okay? This would almost be my answer, but yet again, just like we've done in prior things, we have to resubstitute this u back in here. So it would be is equal to 1/3 e to the 3x plus 1 plus c. This would be my final answer. So it's just like still u sub, but we're trying to get that power to one variable. And once we have it to one variable, then we're good. All right, so the next one. I should see that multiplication does occur everywhere, and I should see that I'm going to have to do some form of u sub because of the fact that there are a lot of pieces that I have to pick up that are not written as far as just one letter. And the fact that this is not one letter shows that I'm going to change it to u. So u is equal to negative x squared. So I'll tell you right now, just like whenever I told you with the examples of the TI-84 calculator, if I were to press e to the power of something, most likely that whole entire something has to be in parentheses. So that's where your u assignment comes, and this is what we've talked about from before. So du is going to equal negative 2x dx. Okay? I see the x and I see the dx. Those got picked up there and there. But that 5 is still lingering, which I'll just move it out. But this negative 2, I have to account for it with a negative 1/2. So it's negative 1/2 times the 5 that got constant multiple rolled out. And the only thing left in there is going to be e to the u du. Okay, so now I have negative 5/2. You can simplify that out real quick. So negative 5/2. And then e to the u becomes e to the u plus c. And I'm multiplying that negative 5/2. And again, technically it's this, But for now, we're not putting -5/2 c. That will come whenever we finish it up with differential equations at the very end of, right before we, right around April Fool's Day. So this will become -5/2 e to the -x squared because we're resubbing it in. And then it'll be plus c. And this would be my final answer for that one. Okay, so the next one. I see an x squared, but I also see a power for e. So most likely it's going to be, it's going to be 1 over x would be u. So we're going to go ahead and write that in. U is equal to 1 over x. And this is the same as, not a natural log, because remember you're taking the differential. Some people want to put natural log of the absolute value. That's not what we're doing. We're taking the differential. So I'm going to rewrite this real quick. I chose to bring that up because of the fact that that is a constant. So I could say du is equal to -x to the -2 dx. Or the same as -1 over x squared, because we've moved it back down because of this negative. And we're going to have the dx. See, now we can identify it a lot easier because we do have the 1. It's an understood coefficient of the top. We have the dx, which is right here. And we have this x squared. The only thing we don't have is that negative. Well, we will account for that in the rewrite. We will say negative e to the u du. Okay, so negative e to the u du becomes e to the u plus c. It has this negative coefficient, and with the rewrite in terms of x will become e to the 1 over x. The negative is the coefficient of e, so it'll be negative e to the 1 over x plus c. Alright. Next problem. Again, I see e to something other than one letter, so chances are that will be my u assignment. So cosine of x. Du would equal negative sine of x dx. And you can already see that most of that got picked up right there. Just we need to account for this negative when we do the rewrite. So negative, it'll be e to the u du. The integral of e to the u is e to the u plus c with a negative out in front. And just like we've been doing for the other ones, we're going to rewrite it with the u substitution that is written in terms of x. So it would be negative e to the cosine of x. And it would be plus c. And that would be my final answer for that one. Okay. So let's move on. Alright, so now we have e to the x over e to the x plus 5. And looking at this, a lot of people might try to cancel these out and you have 1 over 5. Okay, that's something that you should know by now that you can't do because that is not multiplication that exists between that denominator, those denominator pieces. Okay. I would not rewrite it either because there's a variable up top, so I wouldn't try to bring it up. So I'm going to immediately go for my denominator being the u substitution. So e to the x plus 5. So du would equal, the derivative of e to the x is e to the x. And then it would be multiplied with dx. Because technically you're still taking the derivative of that power. Which as a differential, the derivative of this power is dx. Okay? So now we just picked up these two parts right here. So it's basically like saying du over u in the integral, which is the same as 1 over u du, a little bit easier recognizable as far as what we're going to do next. And it'll be equal to the natural log of the absolute value of u plus c. Again, the resubstitution of this absolute value will say it's the natural log of e to the x plus 5 that's in the absolute value plus c. Just a little reminder, this had come up in class a couple times. When do I know and why do we use absolute value? Well, I'm going to use absolute value when I have a variable in the absolute value piece. Okay, if there was an actual numeric value that I could plug in, like x was 2, and I was solving a definite integral with bounds, I could say e to the 2 plus 5 with no absolute value because e to the 2 plus 5 is a positive number. And I could just use parentheses here instead of the absolute value. But anytime you have it still left in x form, waiting for inputs, we want to leave it with the absolute value. Whoops. Because of the fact that the domain for natural log functions have to be existing or greater than positive or greater than 0. Okay, so that would be the answer there. Next one. Because this is one unit on the bottom, I can rewrite this just like you did way long ago when you had like 3 halves plus 5 halves. You could write them together as, say, 3 plus 5 over 2 because you had the common denominator. Well, that's what's going on here. If I were to break it up, I could see it a little clearer as far as what the next step would be. So 3x e to the 3x. See, the reason why I can break this one up and not this one up here was because of the fact that I did not have one monomial, but I do have one monomial here. So I can break it up into 2 separate pieces and then reduce. So 7 over 3 is going to subtract because, again, when we are dividing exponentials with the same base, I subtract their powers. So 7x minus 3x would be e to the 4x. And then subtracting here would show, or even just canceling, would show 1 over e to the 2x. Okay, you could say 1 minus 3 is negative 2 and then rewrite it the way I just did. Or you can know that they will cancel and reduce of that form. Okay? So, we have too many problems here. The very first one we will do e to the 4x. Okay, so I'm going to break it up just real quick so you can see the steps. E to the 4x dx, and the other one is 1 over e to the 2x, and it'll be dx. Okay? So let's do the e to the 4x first. Well, u is equal to 4x. du is equal to 4dx. So the rewrite, and again, we did this u substitution because this power was not just one letter. It wasn't the one letter that was equivalent to its in terms letter. So it'll be e to the u du, but again, this 4 says we have to account it with a 1/4. So e to the u, 1/4 of that, du, is going to equal e to the u plus c, and the 1/4 is tacked in front. And again, this would go down as saying e to the 4x. So ultimately, for this first one, it's 1/4 e to the 4x plus c. For the second one, it's a little bit trickier. And because of the fact that my constant is the numerator, I could rewrite this as e to the 2x, and it's going to be to the negative 2x. So not the positive power, but the negative power, because I just brought it up. Okay? And it'll be dx, so I could say u, let me get a different color. U is equal to negative 2x. So du is equal to negative 2 dx. So the rewrite is negative 1/2 e to the u du. So e to the u plus c, I would get negative 1/2 e to the u, and I'm going to go ahead and write in what my x value or my u value is. So negative 1/2 e to the negative 2x plus c. So that I can combine this as adding these two together, and I would be done. So negative 1/4, or sorry, positive 1/4 e to the 4x, and you could have written this like this if you wanted to, okay? However you want to do it. So 1/4 of e to the 4x plus this answer, so I'm just going to put minus 1/2 e to the 2x plus c. And I should get that. Okay? Alright, so now let's move on. We're going to do a little bit more practice with e to the u plus c, but now we're going to do it with definite integrals. So u is equal to 3x plus 1. du is equal to 3 dx. So the rewrite is 1/3 of e to the u du. And right here, please don't get points taken off from your test because you didn't change your bounds when you were supposed to. Plugging in the 1, we get 3 plus 1, this would change to 4. Plugging in the 3, we would get 9 plus 1, this would change to 10. This is so that we don't have to go all the way back to the in terms of x and using those limits of integration. Okay? So this would be 1/3 e to the u is e to the u, the integral of it is, and it's going to be bounded from 4 to 10. Now I will use constant multiple rule just because that's what I do, but you can include the 1/3 in there if you want, because then this would become e to the 10th minus e to the 4th, and it's going to be 1/3 is multiplied with all of that. and that would be your answer. And no, e to the 10th minus e to the 4th is not e to the 6th. E to the 10th divided by e to the 4th, that would be e to the 6th. Okay, because when you're dividing, again, by exponentials, dividing with a common base, you subtract their powers. That is not what's going on here. We're not dividing, we are subtracting. So you can leave your answer just like that, or if you wanted to get rid of the parentheses, you could distribute and say the 1/3 distributes and you get the following. Either one, I'll accept. Okay, so the next one shows we are going to look at a little bit of an alteration here. Well, first of all, let's go ahead and start. U is equal to 1 plus e to the x. Du is equal to, well, 0 is for the 1, so it's e to the x dx again. And I should see that I just picked that up here. Okay? So I'm going to go ahead and write du over u. The new bounds are, so let me highlight it so that you don't forget. 0 is going to plug in, 1 is going to plug in. So the 0, e to the 0 is 1. So 1 plus 1 is 2. Then e to the 1, I'll have 1 plus e. So this is a little bit weird as far as like the way the bound is written. Okay? So let me make a little bit of room. Okay? So the integral of this guy right here is natural log of u, the absolute value. Again, because that looks like 1 over u du, just like we did before. It looks like this if you were to rewrite it to something that looks a little bit more familiar to you and what you have memorized. So the natural log of the absolute value of u, and it will be evaluated from 2 to 1 plus e, because this is a definite integral. This is the natural log of 1 plus e. Now, 1 plus e will always be positive. So I can go ahead and put right now, I can put those parentheses because it's no longer a variable there. And I know 1 plus 2.71828, which is the constant of e, it's going to be positive. Okay, so let's say that it was 1 minus e. Well, then I would still put 1 minus e, and whatever answer I got, then I would take the absolute value because the domain of a natural log function is greater than 0. Okay? So that's whenever the absolute value signs matter. Okay? In this predicament or this example, I'm telling you 1 plus e is positive. We can write it as parentheses. So it'll be minus the natural log of 2. And again, 2 is positive, and it will be defined. It's not going to be undefined. We can write it as this. So you could write this as your answer, or if it's a multiple choice on the AP exam, chances are you may see it as 1 plus e over 2. And that's because it's using the law of logs. You have the same natural log function subtracting, therefore it yields bringing those two arguments together with a division, because subtraction yields division. Okay? So let's move on to the next example. Here you should see that you're going to do use substitution again. Now, something that I want to point out right now, I do have low to high. Negative 1 to 0 is low to high. If it was 0 to 1, or 0 to negative 1, it'd be high to low. Okay, because you always read the bottom and then you read up. Okay, so looking at this, negative 1 is a lower number than 0, so it's written correctly. But if it was written like this, you could still work it out, but some people might miss negatives. So another rewrite would be negative 1 to 0 with a negative out in front. Now, it doesn't apply here. I just wanted to make sure, just bring that in as far as, because I don't want people making negative mistakes on the test as much as possible. Alright, so let's leave it as it is, and we're going to go ahead and find u. So u is my parenthetic piece that's a little bit more obvious, is e to the x. So du is e to the x dx, which that just got picked up here and here, so that I could say this integral is going to be the rewrite. Let me do it in a different color. It's going to be, we'll put negative 1 in there. So negative 1, e to the negative 1 is the same as 1 over e. Okay? And then e to the 0 is 1, because I changed my bounds. So it'll be the cosine of u du. Well, by now you should know the integral of cosine is sine. So sine of u evaluated 1 over e to 1, we could say is going to equal sine of 1 minus the sine of 1 over e. And as weird as this looks, this is your correct answer. Okay? No, the sine of 1 is not 0. If you're thinking that right now, the natural log of 1 is 0. The sine of, let's say, pi over 2, that's 1. And the sine of 0 is equal to 0. And that's from the unit circle. Just a little recap there. And yes, I can leave this as a fraction because it is not a complex fraction. It's not a square root in a denominator, nor am I showing a negative power. Okay? So now let's solve the differential equation. So solving the differential equation is getting f of x equals the answer, or y is equal to the answer. The solution is whatever you get there function-wise. Okay, so we know we're going to have to integrate both sides because we want the dy dx to become just y equals, and we're going to integrate both sides in respect to x. Okay, another way that you can see that some people might want to think about, because you're going to do it soon anyway when you come back from spring break, is I know that you're not dividing by this dx. However, if you were to multiply by a differential, those cancel, and you have now the dx over here. So technically you have dy is equal to x squared ex cubed dx. So that when I integrate both sides, this differential of dy just becomes y. And now I have this over here as far as I can integrate it in respect to x. Okay. Now again, true multiplication or true division does not occur there, but it's a way that we can view it just to alter and set it up so that we can integrate thereafter. Okay, so let's go ahead and integrate this. Once we get the integral, that will be our answer. So u is equal to, again, I should see that my u assignment will be x cubed, because the integral of e to something has to be one letter. So x cubed, du is 3x squared dx. We just picked up the x squared dx, but we have to account for this 1/3. And then we'll have e to the u du. So this becomes 1/3 e to the u. And it's going to be resubstituted with the x cubed, and it will be plus c. So the solution to this differential equation is y equals, or if you want to write f of x equals, that would be fine too, 1/3 of e to the x cubed plus c. Alright, so again, you can write y equals there or f of x, but you have to have it there for the test because you're showing it as a position function. Alright, so next one. Find the particular solution. So when you see that particular, it's not going to be something with c. C will be found. Okay? So we have a derivative, and we're trying to get to the position function. So we know we're going to have to integrate this thing once. Okay, so let's go ahead and set that up. So the integral of e to the 5x plus sine of x, it's in respect to x. I should see that the first one, and again I can break this up in two if I wanted to combine them together. At this point in time I think we can pretty much do it together without breaking it up. So u is equal to 5x, du is equal to 5 dx, so 1/5 of e to the u du. Okay, so now it will be broken up because of the fact of I needed to get this in terms of u so that I could integrate in respect to u. Okay? The other one could have remained the same as far as just plus the integral of sine of x dx. Or if you wanted even to go as far as to know that that's going to be negative cosine of x, you could write that in. And before I get the emails, yes, I forgot I wrote the x, or I didn't write the x, so it'll be sine of x dx. Okay? So negative cosine of x, and it is plus c technically. We just have to now figure out this e to the u. So we'll have e to the u bounded. Oh, no, there's no bounds. What am I doing? 1/5 e to the u. And because this was written in terms of x, I have to change this e to the u to e to the 5x. So far, my f of x is equal to, okay, because remember, I integrated that. F of x is equal to 1/5 e to the 5x minus cosine of x plus c. When the input is 0, so when the input is 0, my output value will be 3/5. And it's the output value of the position function. That's why I wrote that where it was. So let's plug in 0. E to the 0 is 1, so technically this is 1/5. Then the cosine of 0. The cosine of 0 is 1 also because of the unit circle. So it's going to be f of x is equal to, or 3/5 that is, because that's my output, is equal to 1/5 minus 1 plus c. Okay, so let's go ahead and combine this together. So I'm going to add 1 and subtract 1/5. So I'm going to add 1 over there plus 3/5, and I'm going to subtract 1/5. This is going to be c. And from here I could say this is 5 over 5 because it's a form of 1 that I'm trying to get the common denominator for. 8 minus 1 would be 7/5 is c. So my answer, this is a general solution right now. It will become particular or more exact when I write in the value for c. So the particular solution, my final answer is f of x is equal to e to the 5x over 5, just a different way to write it, minus cosine of x plus 7/5. And that should be your answer right there. Okay, so let's do another one. Find the particular solution for this differential equation. Now we're going to do two levels of derivatives, or sorry, integrals, because I need to get to f of x. And right now I'm 2 levels away. I'm at f double prime. Okay, so let's integrate it once. F prime of x is equal to the integral of cosine of x plus e to the 3x in respect to x. Okay, so right now u is equal to 3x, du is equal to 3 dx. So the rewrite is 1/3 e to the u du. Okay, we know that this integral of cosine should be sine. So I'm going to go ahead and add that, and it'll be sine of x. Okay, and this is equal to f prime of x because we've just integrated one step. So e to the u is e to the u plus c. So this will change to e to the u plus c. I'll write that here with the 1/3, and then putting in back this 3x where u goes, we should have, let me go ahead and rewrite it up here, 1/3 e to the 3x plus c. This right now is my integral for the first step. So I'm going to use the prime values. The input is 0, so I'll put that where x is at. And the output is 7/3. Okay? So, again, sine of 0 is 0. So we have 0 plus 1/3 plus c is equal to 7/3. 7 minus 1 is 6/3. So c would equal 2. So this becomes more particular by saying f prime of x is equal to sine of x plus 1/3 e to the 3x, and it'll be plus 2. Now I'm almost there because I have to get to f of x, not f prime. So we're going to have to integrate again. So the integral of both sides, oops, let me change colors. It's going to be both in respect to x. So this is just finally f of x is equal to, the integral of sine is negative cosine. And now 2 over here is going to be 2x. Okay? And then we'll have our plus c at the very, very end also. So I'll go ahead and put that there, plus c. So all we need to do now is integrate this piece right here. We're going to integrate it in respect to u because of the fact that the power, again, is a composite function. It's not just one letter. So here we go. U is equal to 3x. Okay, so du is equal to 3 dx. So it's 1/3 e to the u du. Now don't forget, it still had this 1/3 originally, so we're going to multiply it in so that it becomes 1/9. Okay, so 1/9 e to the u du is e to the u plus c times this 1/9. We will resubstitute back in our u value so that we get plus 1/9 e to the 3x plus c. Now the plus c I wrote at the very end. We only need one of them. So I'm going to go ahead and move this over just a little bit so it's a little bit neater. 1/9 e to the 3x plus 2x plus c. Okay, so from here we're going to solve for c. Let me make some room. You can rewind the video if you need to. And we're going to use this value here. So our output is now going to be 2/9. So we'll put 2/9 is equal to, again, we're going to plug in 0 right here and right here and here. So the cosine of 0 is 1, but it has a negative coefficient, so it's negative 1. E to the 0 is 1, so it's plus 1/9 plus 0 plus c. So I don't even have to write that 0. I could just say plus c. Okay, so plus 1/9 plus c. Oops, that's a little messy. 9 plus c. Alright, so I'm going to add the 1 and subtract the 1/9. So 2 over 9 plus 1, so plus 9 over 9 minus 1/9. So it'll be 11/10. C is equal to 10/9. So that I can write this as a very final answer, this plus c will become plus 10/9. And now this would become my particular solution because c is found. Okay? Alright, so now let's move on to the next problem. Next problem says the rate at which the water is pumped or is being pumped into a tank. So this saying that it's a rate, we know rate of change, says it's the derivative. This is an f prime of x function right here. And where t is in minutes and r of t is in gallons per minute. So there's another hint that it's going to be a rate function of f prime of x because of its units of measure. How many gallons of water have been pumped into the tank in the first 5 minutes? So we're going to say from 0 to 5, that's the first 5 minutes. Now we can use a calculator to get the answer, but I'm going to show you just how you could set it up without a calculator. 20 would come out, constant multiple rule, e to the 0.02t dt. So u would equal 0.02t. du would equal 0.02 dt. Now 0.02 is 2 tenths hundredths, so it's 2 hundredths. And what we're going to do is do the opposite. So if it's 2 hundredths right now, when I do the rewrite, or 2 hundredths is the same as 1 over 50 if you want to reduce it. And that's equivalent to this. When we do the rewrite, it would be 50 over 1. So 50 over 1 times e to the u du. Now I know I still have to multiply this 20 in. So 20 times the 50, it's really going to be 1,000. So 20 times 50 will be 1,000. Okay? So 1,000 e to the u du. What I'm missing right now is I haven't changed my bounds yet that I'm going to put here. Again, we know 0.02 is 1/50th. So we say u is 1/50th of t. So when I put 0 in, 0 divided by 50, or 0 times 1/50th, is going to remain 0. Okay, again, I'm putting in these bounds right here where this t is at, so that I could get the new limits of integration in terms of u. And then putting 5 in there, 5 times 1/50th is going to be 1/10. Okay? So from here I could integrate and say this is going to be e to the u from 0 to 1/10. So it's going to be like e to the 1/10 minus e to the 0, which is just 1. Because anything to the power of 0 is 1 except for 0 and infinity. So e to the 1/10 minus e to the 0, which is 1, is all going to be multiplied, whatever this is, with 1,000. Constant multiple rule. And if you put it in your calculator, you get it to 3 decimal places, and you would be correct. Okay, we're almost done. We're almost done. We have basically your last page of notes. Now, use your calculator if needed to solve for x. Okay? Give decimal answers. You have a solve feature. I shouldn't really have to show you this, but what I am going to do with these problems is a little bit of manipulation to solve for x. Just to recap, this is written in exponential form. The best way to solve an exponential function is to rewrite it in log form if I were to do it by hand. So log base 2, because that's your base, of 45 is equal to 3x. Now, the reason why I know this to be true is because if I were to do the reverse Hart method, I could rewrite it back to the exponential. 2 to the power of 3x per reverse Hart method is equal to 45, which is what I originally had. So now I could just put this in the calculator and divide by 3. So x is equal to the log base 2 of 45 divided by 3. Whatever that is, that would be your answer. So a little bit practice with hand. So now this is in log, so I will rewrite it in exponential. 5 cubed is equal to x minus 2. Again, that's the reverse Hart method. And we know this to be 125 is equal to x minus 2. So 127 is equal to x. With no calculator, we don't need it. Okay? Now let's move on. By now, you should know the derivative of this guy, whenever it's in terms of u, it's saying it's not just the letter x. It's like 2x squared or 3x cubed or something like that. So when you're deriving in respect to x, you need to multiply by the derivative of the cream. Just like, whoops.
Ethan Burton, if you are still in the school, please come to the front office.
All
Ethan.
right, sorry for the interruption. All right, so here we go. The next one will be deriving in respect to x, saying u is something composed of something else, like 2x squared again, 3x cubed, or something other than just the letter x. So we have to multiply by the derivative of the cream. The integral of e to the u is e to the u. There's no multiplying by no derivative of the cream. Okay? So here is where it's going to get a little bit weird as far as the rules that we will do for derivatives and integrals. So right here, log base a of u is the same as if I were to say like the log of u divided by the log of a. Okay? And this is the same as if I were to do the natural log of u. It goes over the natural log of a. Now, a is a constant. U is a variable. So right here, pay close attention. If u is a variable and a is a constant, then 1 over natural log of a can be constant multiple ruled out. So where I'm just looking to derive natural log of u. So what is the natural log of u? Well, the natural log of u's derivative is 1 over the stuff times the derivative of the stuff. And that is what you see, let me highlight it in purple, 1 over the stuff times the derivative of the stuff. And this natural log of a, which people struggle with, is a constant. That is like, it almost feels like a 1/2 in a problem like if you had x to the 1/2, it'd be 1/2 times x to the negative 1/2. It almost feels like this denominator of that 1/2 piece. Okay? So that natural log of a is remaining on the bottom as a constant. Okay, so when you see that, and this is again when the log is something like log base 2 or log base 3, it isn't log base e. So log base e is natural log. That's just 1 over the stuff times the derivative of the stuff. When that e is something other than e, like 2, 10, 3, whatever it is, we have to do this form of the derivative. Okay? I would say the very first thing is to do what I did. Log of u over log of a, equivalent to natural log of u over natural log of a. bring out in green that constant multiple rule piece. So therefore, you're just going to derive in orange this piece, the natural log of u, which is 1 over the stuff times the derivative of the stuff. All that multiplied, and you would get what you see on your paper. Okay? So if you want to just memorize the rule and remember that a is a constant, and then just do everything as normal, 1 over u times du dx, well then you'd be good. Otherwise, in case you forget this, you could rederive it on the spot, you could figure it out. Okay, so finally, this one's easier. So a is a constant, so we could say it's like 2 to the u, and the derivative of this is the carbon copy times the natural log of the base times the derivative of the power. And this is where it's different from what we've done with e to the u. E to the u is just the derivative is the carbon copy times the natural log of the base times the derivative of the power. See, this is an understood 1 whenever the base is e. But when the base is not e, you can't just think, oh, this is going to be 1, so it's irrelevant. I don't even have to write it. No, you do need it because of the fact that natural log of 2 is not 1. Okay? So it'd be the natural log of a times the carbon copy times the derivative of the cream. Or, like I said, the carbon copy times the natural log of the base times the derivative of the power. So that should be a lot easier than this one. I think this one right here that I'm starring is the one that trips most people up. And then this one trips them next. Okay? So, like up here, like over here, the integral of e to the u is e to the u du. Well, here, think about this, the way I just said it, carbon copy times the natural log of the base times the derivative of the power. Well, here, it is the carbon copy divided by the natural log of the base. And technically, it's times the derivative of the power. But the derivative of the power is going to remain itself because you don't have a dx piece out here that you're trying to put it still in terms of x. Okay? So the integral, just like we've done over here with e to the u, is itself plus c. We'll say it's the carbon copy divided by the natural log of the base plus c. There's no I have to derive by the integral of the power because technically, there's no I have to multiply by the derivative of the power because the derivative of the power here is just 1. It's not something written in terms of x. See, that's the difference here. You have u and x, but here you have u and u. So technically, if you wanted to say, you're multiplying by 1 here before you add the c. Okay, so if you need to rewind that, go ahead and do so. But in summary, it's just the derivative is carbon copy times the natural log of the base times the derivative of the power. Here, it's the carbon copy divided by the natural log of the base times 1, an understood 1. Okay, so let's go ahead and go to some example problems. We have the derivative of 2 to the x squared. That's pretty simple because it is an exponential function. I shouldn't be thinking that this is going to be 6x squared. Some people make that mistake. They see 3, 2, they multiply, and then they just bring down the power. But it's not that. It's the carbon copy times the natural log of the base. Oops, and my carbon copy is off before I get the emails. 2 to the power of x cubed times natural log of the base times the derivative of the power. And then if you wanted to simplify this out, you could. You could write it out as 3x, or reorganize it, 2x to the power of x cubed times the natural log of 2. And this is the answer here. Please, please, please don't make the mistake to multiply 2 and 3 together and put 6 there, because those are not the same thing. 2 is a base of an exponential function, whereas 3 is a coefficient of a quadratic function. Those are not allowed to be multiplied together to become 6. Okay, you just leave them separate. Let's do our next example. Alright, so I have log of 3. If you don't have this rule memorized, you can always break it up as far as like natural log of x squared plus 1. over the natural log of 3. So that I know in my answer, I'm going to have the natural log of 3 in the denominator. That's what you see right here. Okay, for the base, natural log of 3. Okay, so then it's basically like I can look at this and take it out so that the derivative becomes 1 over the stuff. So that x squared, that u term, is going to go downstairs with it. I'm going to highlight that here in a bit with parentheses. There's that u term. And it's going to be multiplied by the derivative of the stuff. So that'll just be 2x. Now put that on top. Even though right here it's written there, I can put it on top. Because I know the derivative of the cream is 2x. And then that would be enough. Like, don't even worry about even simplifying that. You don't have to. Okay? And then, let's do some integrals. The integral of 2 to the x. Okay? So the integral of 2 to the x, because of the fact that it's not e, the integral of e to the x is just e to the x. Or the integral of e to the u is just eu. But because this is a base other than the number, or other than e, we're going to use this guy here. So it's the carbon copy divided by the natural log of the base plus c. This would be the integral for that one. Okay, so this one's a little bit involved. We have to do use substitution. X cubed. So du is equal to 3x squared dx. You see the x squared and dx got picked up right here and here. So we will rewrite 1/3 of, not e, 1/3 of 3 to the u du. And again, we're going to use this law right here. It's the carbon copy divided by the natural log of the base, so the natural log of 3 plus c. The 1/3 gets multiplied back in, as well as the use substitution. Okay, so you should see right now that these 3's are multiplied, so I can cancel them. Oh, no, I cannot. Now I'm glad I made that mistake. Good teachable moment. It's not 3 times u. It's 3 raised to the power of u. Okay, so those will not cancel. So it's 3 raised to the x cubed over 3 times the natural log of 3 plus c. And if you wanted to, just a recap of law of logs that you should kind of know, this can be moved there because of a property or a law of logs. And it would be natural log of 3 cubed. So if you wanted to, you could say the natural log of 27. And then you could have 3 to the x cubed plus c. This is as difficult as it gets before spring break, okay? I mean, this is pretty, I know it's a little bit involved, but if you practice and practice with WebAssign, you'll be fine with this. All right, our last problem. If you are asked to differentiate a function that contains a variable raised to a power that contains a variable, okay, so that's different. Like we're doing it as far as integrating raised to a power, but we have the variable downstairs as well. We didn't really have that before. We had numbers before, but now we're going to do where we have the variable on top and on bottom, or the power and on the base. Okay, so we're first going to find y prime in terms of x. Okay, so let's go ahead and do that right now. So finding y prime in terms of x. Okay, okay, so just like I was saying, if I were to derive it right now, I'd have dy dx is equal to, what you would think to do right here is you would think it's the carbon copy times the natural log of the base times the derivative of the power, which is just 1. The reason why you cannot do that is because this base is not a number all by itself. It's not a constant. This base is variegated. It has a variable in it. So I can't use this differentiation as far as exponential laws is the carbon copy times the natural log of the base times the derivative of the power, because of the fact that this is not just a number. Okay, so I have to do something called logarithmic differentiation. Okay, so what we're going to do, first step, is we're going to take the natural log of both sides. So the natural log of y is equal to the natural log of x plus 1 to the x minus 3. Okay, Now, right now, I can use law of logs to rewrite this so that I have x minus 3 times the natural log of x plus 1. Okay, because it's a power, I can rewrite this, and now it's going to be multiplied from our law of logs. Okay, so everything else is the same, the natural log of y. So now what we will do, the second step, is we're going to differentiate. So 1 over y dy dx. Okay, 1 over y, 1 over the stuff times the derivative of the stuff. And again, just to clarify, we're trying to ultimately get dy dx, because that's what we're being asked to find, the derivative in terms and also in respect to x. So over here, I'm just going to differentiate it in respect to x. So I can use it as the power rule, or if I wanted to distribute this, I could do that. The product rule, or if I wanted to distribute it like x natural log of x plus 1 minus 3 natural log of x plus 1. I can do it like that. I'm going to use the product rule. So the first times the derivative of the second, which is 1 over the stuff, times the derivative of the stuff, which is just 1, plus the second times the derivative of the first, which is just 1 again. So from here, what I can do is, let me clean this up a bit. I'm going to put x minus 3 over x plus 1 together. So x minus 3 over x plus 1 plus the natural log of that. Okay, so then now what I'll do is I'll multiply y over. So when I multiply, that'll be my third step. Okay, so third step is to move the y. So multiplying multiplying both sides by y, this would all get multiplied by y, and this would get multiplied by y, so that the y's cancel, and I'm left with dy over dx is equal to what I have over here. Now, because of the way it's written, I can just straight up resubstitute this back in. So x plus 1 raised to the x minus 3 is going to be multiplied, there's that parentheses, x minus 3 over x plus 1 plus the natural log of x plus 1. And this would be your final answer. All that is the derivative. And the reason why I had to do that was because I can't say, like I said at the beginning of this problem, the carbon copy times the natural log of the base times the derivative of the power. I can't do that because of the simple fact that the base was not a constant number all by itself. That was like 2, 3, 5, something other than of course 0 or infinity, but something other than e. And that's it, guys. That's it. We are done with this unit. Please make sure that you know how to do this logarithmic differentiation, because you definitely would have one on the test. All right.